Welcome to week 2 of Honors Physics. This will be rolled out on the 15th and will be due by Tuesday evening, the 21st. This week, you will be learning how to represent and interpret either nearly constant speed or velocity motion with both numbers as well as graphical data. Just like last week, you will have 3 activities to undertake. The first one going through this video, which is linked at this icon, to go through our targets and success checklist, as well as the content. By doing this, you'll be able to differentiate between distance and displacement, as well as speed and velocity. You'll be able to find average speed or velocity with a distance or displacement versus time graph. You'll also be able to convert speeds between both metric and English units. And lastly, by doing the week 2 practice Google form and the run/walk activity, you'll be able to create a distance versus time graph from collected data, and will also be able to graphically find average speed. As always, your links down here to our Google Classroom, your email, as well as the Google Meet, which I will always have office hours from 11 a.m. to 1 p.m. each day. This is review obviously from earlier in the year, right? Distance is a scalar quantity while displacement is a vector. Distance just tells you how far an object has moved. It does not include direction. It cannot be negative. On the other hand, displacement does include direction, hence it's a vector. And mathematically, it is the difference between an object's final and initial position, right? So in this picture here, the displacement would be the distance along this black line, right? Also including the direction. Distance covered, though, would be the path along the dotted red pathway. Okay? If you need any more help with this, there's an embedded Khan Academy video here that once again goes through the differences of distance and displacement. Another 2 quantities that we've dealt with, both speed and velocity. Once again, their difference comes down to one being a scalar, which is speed. Velocity is a vector. Mathematically, the equation for speed is an object's distance covered divided by time, while for velocity, it's displacement over time. Okay. Speed will always be positive because if you're using distance, which is always positive divided by time, hence it'll come out that way. Velocity, on the other hand, because it's a vector and depends upon displacement, can be positive or negative. Right? Once again, here's an embedded Khan Academy video if you need a refresher on this. And I would highly suggest, even if you don't watch the Khan Academy videos, that you practice with the 2 links below here on the bulleted items from the Physics Avery. There are 2 different practice interactive games dealing with these 4 quantities. Quick review of the graphical nature of this. We can find speed or velocity from graphs of either position versus time or distance covered versus time. Technically, if you take a position versus time graph, the slope will give you velocity. It could be positive or negative because you could be moving forward or backwards. Speed would be the slope from a distance versus time graph. And distance would always be positive. So your lines would always have a positive slope to them. Or you could also get speed from a position time graph if you just ignore the sign of the slope. Many of you would just say that that's just making it positive. Right? This is from one of our set of notes earlier in the year. If we were given a position versus time graph that looked like this, could we find the velocity in each section? Notice we have 1, 2, 3, 4, 5 different sections of motion. In the first one, we move 20 meters forward in 2 seconds. The slope of that is positive 10 meters per second. From 2 to 4 seconds, as well as from 10 to 12 seconds, notice the position is staying the same. That means you have no motion. That would be a velocity of 0, all right? Hence the slope of this section is 0. From 4 to 7 seconds, we're working backwards, so we lose 10 meters in 3 seconds, which leads to a velocity of negative 3 1/3 meters per second. And from 7 to 10 seconds, we gain 5 meters in a time period of 3 seconds. That slope would be 1 2/3 meters per second. Okay. In your activity, we're going to be asking you to either run or walk outside. Get yourself outside, get your blood moving. And we want you to take a path that you can repeat 5 times. For instance, if that's walking around the block, you could get 5 different elapsed times for each time you go around the block, or if you're running in the park or whatever it might be. And you can use this interactive regression, a linear regression fit from Desmos to plot your data as part of your project. So if you just click on this, okay, it'll take you to a Desmos sheet, which I kind of created here for you. And what it'll automatically do is it will do a best fit line. I'll take this away here, where it gives you the slope of a line and it's forced through the origin, right? Because obviously 0 distance would be 0 time. And you can change the X and Y data, where the X is the time elapsed and the Y would be the distance covered. Just make sure if you're doing this in feet, you understand it's in feet, or if it's in miles. Are your times in minutes? Are they in seconds? Just be consistent. Okay, so you can use this thing to help you through that activity. Okay, please make sure you read the directions in the activity, finish up the Google form practice for week 2, and hope everyone is doing well.